the sixth class, my dear students. So we almost all we completed the chapter motion in a plane in the previous class. So motion in a plane, that motion content even we discussed some of the numericals. So that numericals are enough for in the online class. When you just come out for the offline classes, in that classes I will just explain you how to solve some more numericals in that chapter. Why? Because in that chapter, especially that there is what splitting up of a vector into two components will be present. So that is very important to know. So in the online class you may get clear about that numericals or not. For that reason I am not going to go with those kind of numericals, but once you come back to the school I will just go with those numericals, right? But now let us start with a new chapter, that is work, energy and power. This is the third chapter I am dealing with in the first PUC. My dear students, you can observe that I just want to define work, right? You know, my dear students, even you discussed, even you studied work, energy and power in your 8th, 9th and even in your elementary classes. You know that before entering into the 9th class, in your elementary classes, you define that work is a form of energy. It is a simple definition. Even you now also, you might have, so many of you might have recollecting that definition, that work is a form of energy. And suppose if I ask you that what is the definition for energy, you can say that energy is a capacity to do work. But these two are interrelated terms, definitely. Work is depending, work and energy are interrelated terms. But how to define work, how to define energy, what is power? So we are going to discuss each and everything in detail in this chapter. In your 9th class, you define that work is a product of force and displacement. Even you said that if there is a presence of force, but if there is no displacement, then we can say that the work is said to be not done. So to say that the work is said to be done, there should be a force, and also due to the application of the force, the displacement should be present. If we have a force and no displacement, if we don't have both force and displacement, then we can say that the work is said to be not done. So work ಆಗಿಲ್ಲ ಅಂತ ಯಾವಾಗ ಹೇಳ್ತೀವಿ, ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರು ಕೂಡ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಗಿಲ್ಲ ಅನ್ನೋ ಆಬ್ಜೆಕ್ಟ್ ಅಂದರೆ ನಾವು ಅದನ್ನು ವರ್ಕ್ ಡನ್ ಆಗಿಲ್ಲ ಅಂತ ಹೇಳ್ತೀವಿ. ಈವನ್ ಫೋರ್ಸ್ ಇಲ್ಲ ಜೊತೆಗೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕೂಡ ಇಲ್ಲ ಅಂದರೆ ಸೊ ವರ್ಕ್ ಆಗಿಲ್ಲ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಯಾವಾಗ ವರ್ಕ್ ಆಗಿದೆ ಅಂತ ಹೇಳ್ತೀವಿ, ನಾವು ಅಪ್ಲೈ ಮಾಡಿರೋ ಫೋರ್ಸ್ಗೆ ಆಬ್ಜೆಕ್ಟ್ ಮೂವ್ ಆಗಬೇಕು. ಸೊ ಅವಾಗ ಮಾತ್ರ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ, ಸೊ ವರ್ಕ್ ಡನ್ ಆಗಿದೆ ಅಂತ ಹೇಳ್ತೀವಿ, ರೈಟ್? ಸೊ ನಾವು ಲೆಟ್ ಅಸ್ ಡಿಫೈನ್ ದ ವರ್ಕ್ ಡನ್. My dear students, work done, the definition of work, right? So you can take down the heading work. So what is the definition of work? You said that work is a product of force and displacement. See, I'm just going to write work is a product of, or is defined as a product of displacement along the direction of force, right? See, work is a product of force and displacement along the direction of force. It means ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ನಾವು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿರ್ತೀನೋ ಆ ಡೈರೆಕ್ಷನ್ ಇರ್ತಕ್ಕಂಥ ಒಂದು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ನ ಫೋರ್ಸ್ ಜೊತೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ, ರೈಟ್, I will get work. So how to write? So simple like I can write it as W is equal to F into S. W is equal to F into S. This is simple definition for work done. You work only, just take it down in your notes. Work is a product of force into displacement along the direction of applied force. Yes, and my dear students, we should be very careful that while substituting the values of P, F and S. So ಇದನ್ನ ಯಾವ ತರ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡೋದು, ಯಾವ ತರ ಇದಕ್ಕೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅನ್ನು ರೆಡ್ಯೂಸ್ ಮಾಡೋದು, ಇದು ಸಿಂಪಲ್ ಡೆಫಿನಿಷನ್ ಬರಲಿ, ಸಿಂಪಲ್ ಫಾರ್ಮುಲಾ ಬರಲಿ. So this formula is from which class? 9th class. But I want to show you the expression and also the diagram to write the exact formula for work done. So how to write that? See here, I am just going to put an heading, expression for work. Expression for work. So simply get an expression also because work and I am very. See my dear students, I am going to consider an horizontal surface, right? I am going to consider an horizontal surface. On this horizontal surface, I am going to place a block of mass m. See, this is a block of mass m. So I just placed an object here. Right. I just placed a block of mass m on the horizontal surface. My dear students, now I am applying, this is said to be a block, right? So I am just using a block of mass m. So just you can write it as, this is said to be a body of mass m. Right. Now I am applying the force. So my dear students, I am applying the force on this body, so in this direction. My force is in this direction. Force is a vector quantity, so I am writing it as F arrow mark. F I just written with arrow mark, so it indicates that F is a vector quantity. So ಇದನ್ನೇನು ಮಾಡ್ತೀನಿ? So ಈ force ನಾನು ಏನು ಮಾಡ್ತೀನಿ? Two components ಆಗಿ divide ಮಾಡ್ತೀನಿ, right? One is along x axis and another one is along y axis. ನಿಮಗೆ ಮುಂಚೆನೇ ಗೊತ್ತಿದೆ. Along x axis we can write it as F cos theta, and along x axis we can write it as F sin theta. ಯಾವಾಗ x axis ಅಲ್ಲಿ cos ಅಂತ ಬರೀತೀವಿ, y axis ಅಲ್ಲಿ sin ಅಂತ ಬರೀತೀವಿ. See, now I applied a force on this body. Due to the application of a force, this object starts moving from one point to another point. ಈ point ಇಂದ ಏನು ಮಾಡುತ್ತೆ object displace ಆಗುತ್ತೆ, ಮತ್ತೊಂದು ಹೊಸ position ಗೆ ನಿಂತುಕೊಳ್ಳುತ್ತೆ. ಹಾಗಾದ್ರೆ how much displacement has made? X displacement. ಎಷ್ಟು displacement ಮಾಡಿದ್ರೆ? X is the displacement made by the object. X is the displacement made by the object. See, F is a force applied on this object. Due to the force applied, it has displaced from one position to another position. The displacement is X. See then, F is divided into two components. One is along the direction of applied force and another one is vertical direction. One is F cos theta and another is F sin theta. Observe ಮಾಡಿ, ಇಲ್ಲಿ observe ಮಾಡ್ತಿದ್ದೀರಾ? So whereas the angle which is present between the displacement X and the applied force F is theta. And it is not an angle between F cos theta and F. Theta is an angle present between force and displacement, because this is exactly equal to this F cos theta, right? Now horizontal direction F cos theta ಅಂತ ಬರೀತೀವಿ, but ಇದನ್ನ X ಅಂತ displace ಆಗುತ್ತೆ. The theta is the angle present between force F and the displacement X. Now write down this diagram. So after that, in the next line, right? From the figure, in the next line, F is the force acting on the body. Next line, X is the displacement made by the body. Pause the video and you can write. In the next line, F cos theta is the force along the direction of displacement. In the next line, F sin theta is a force perpendicular to the direction of displacement. See, because F cos theta ಅನ್ನೋದು displacement ನ direction ಗೆ ಇದೆ, ಅದಕ್ಕೆ along the direction of displacement ಅಂತ ಹೇಳ್ತಾರೆ. F sin theta ಅನ್ನೋದು displacement ಈ ಕಡೆ ಇದೆ, ಇದು straight upwards ಅಂದ್ರೆ 90 degree ನಲ್ಲಿ ಇದೆ. So I said F sin theta is perpendicular to the direction of displacement. Full stop. In the next line, theta is the angle between force F and displacement X. See what I said? Force F on the head. So how to write? Force F. Single inverted comma. Force F and displacement X. Single inverted comma. Right. So this is what you should write down here. Next. So So now I want to write the formula. You can write where m is the mass of the body, where m is the mass of the body. So thus the object is having a mass m. Now I want to write the formula for W, right? From the definition. So what is, you can write this one from the definition of work. So what is the definition of work? So work done is equal to, what is the formula actually? So work done you can write like this also. Work done is equal to, it is a product of force into displacement. So you can write that the component of force along the direction of displacement into the displacement. I am just going to write that the force component of force along the direction of displacement, along the direction of displacement, along the displacement into displacement. Yes, observe right? F cos theta is a force along the direction of displacement. So, and F sin theta is a force along perpendicular to the direction of displacement. So, F cos theta is a component of force along the direction of displacement. F sin theta is a component of force perpendicular to the direction of displacement. However, how to write this force? This force can be written as this force can be written as F cos theta. This can be written as F cos theta into displacement can be written. And we get 9th class we know only that work done is equal to F into S, F into X or F into D. But in a clear formula, work can be written as Fx cos theta or Fs cos theta or Fd cos theta. So this is about writing of the formula for work done. But my dear students, so we will observe the formula W is equal to Fx cos theta. So from your so we go in dot product and vector product scalar product as well as vector product. How to write the scalar product? Scalar product scalar product of the two vectors A dot B can be written as A B cos theta. Right? That vector product vector product or the cross product of two vectors A and B can be written as A B sin theta. But W is equal to Fx cos theta. So it is in the form of Fx cos theta formula. Here it is. So I can use dot product and in place of A and B we have F and X. According to that formula, how to write this one? You can written as F dot X. So work done is equal to dot product of two vectors F dot X. So this is also one of the example for your dot product. Make formula by so you can the like the 9th standard W is equal to F into S you marks F into S you will get 0 marks. Why? Because work done is a dot product of force and displacement. So this is a formula for work done. So in terms of cos theta, this is a formula for work done in terms of dot product. So with the help of dot product and vector product, we have written another one formula. So take on the next heading. Mention the expression for the work with the help of dot product. Mention the formula for work done with the help of dot product. Yes. So in the next line, right? W is equal to vector f dot vector x. Put it in a box. Next finally, w is equal to f x cos theta. Right? ಯಾಕೆ ಇದರ fx ಅಂತ ಬರೆದ್ವಿ? Because we know that the dot product of two vector gives you ab cos theta. Because of the bracket ಬರ್ಕೋಬಹುದು. Right? Okay, hope this you got it. ಇದು ಗೊತ್ತಾಗಿದೆ ನಿಮಗೆ. ಈಗ now let us see when will be the work done becomes maximum, when the work becomes minimum. So ನಿಮಗೆ ಗೊತ್ತಿಲ್ಲ what are the two important factors responsible to explain that the work is said to be done or the work is said to be not done ಅಂತ force ಮತ್ತು displacement ಬೇಕೇ ಬೇಕು. So my dear students, suppose ನಿಮಗೆ ಒಂದು example ಕೊಡ್ತೀನಿ. If I just apply the force, on this wall, so what happens? I am doing my work, right? So I am spending my energy, I am going to lose my energy just pulling this wall, but the wall is not moving, the wall is not displacing its position. So move agilla wall and that force is there, but displacement illa. Displacement ಏನಾಯ್ತು? 0 ಆಯ್ತು. Displacement 0 ಆಯ್ತು ಅಂದ್ರೆ work done ಏನಾಗುತ್ತೆ? 0 ಆಗುತ್ತೆ. ಅಂತ ಟೈಮಲ್ಲಿ we have applied a force but there is no displacement, then we can say that work is said to be not done. ಅಥವಾ displacement 0 ಆದರೆ work done 0 ಆಗುತ್ತೆ ಅಂತ ಹೇಳ್ತೀವಿ. So this is one set actually. So ಇದನ್ನ ನಾವು ಅಪ್ಲೈ ಮಾಡೋಣ ಯಾವ ತರ ಇರುತ್ತೆ work done ಅನ್ನೋದು. Take down that now writing of the special cases ಅಂತ ಹೇಳಿ. We are going to discuss 3 special cases here, right? Special cases. So first one is when theta is equal to 0 degree. Right. Similarly, the second case is when theta is equal to 90 degree. When the third case is when theta is equal to 180 degree. Right. So you can observe carefully. 0 degree and the angle between force and displacement is 0. 90 means the angle between force and displacement is 90 degree. It means force and displacement are perpendicular to each other. ಇಲ್ಲಿ force and displacement are parallel to each other. But theta is equal to 180 degree. It means the force and displacement are opposite to each other. Right. So now let us observe the 3 cases clearly. ತುಂಬಾ ನೀಟಾಗಿ 3 cases ನ observe ಮಾಡೋಣ. See in first case ಏನಿದೆ theta is equal to 0 degree ಅಂತ ಇದೆ. Right. So ಅದಕ್ಕೆ ನಾನು ಏನು ಮಾಡ್ತೀನಿ? I am just going to write an object here. So this is my object. So which is placed on an horizontal surface. Right. So I am going to write this is a body of mass m. Right. So similarly for 3 cases I will write the body of mass m. So this is a rough surface. On the rough surface I am going to place a body of mass m. Right. But students, in this case, if I apply the force in this direction, right? So if I apply the force in this direction, what happens? The object moves in the same direction. Object moves in the same direction. So that you can observe force and displacement both are parallel to each other. So very good. Force and displacement are parallel. So then what happens? Theta is 0. Now work done ಏನಾಗುತ್ತೆ? What happens to the work done now? So I'm just going to write that. Work done formula is f x cos theta. So here, what is f? What is x? They are same as it is. Cos 0. Cos 0 is 1. So cos 0 is 1. Right? Cos 0 is 1. So again the work done it becomes f into x. It becomes f into x. Right. ಸಿಮಿಲರ್ಲಿ ಇದು ಡಿಸ್ಪ್ಲೇಸ್ ಆದ್ಮೇಲೆ ಹೊಸ ಪೊಸಿಷನಿಗೆ ಬಂದಿದೆ, ಮೂವ್ ಆಗ್ಬಿಟ್ಟು ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಬಂದಿದೆ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ದಕ್ಕೆ. ಫೋರ್ಸ್ ಯಾವ ಕಡೆ ಅಪ್ಲೈ ಮಾಡ್ತೀವೋ on the same direction the displacement is present. Let us come to this position. Let us come to this position. If the force is in this direction and the displacement is in this direction. Force ಈ ಕಡೆ ಇದೆ and the displacement is along this direction. ಹೇಗೆ ಮಾಡೋದು? How to explain this? ಹೇಗೆ ಇದು ಅಪ್ಲೈ ಮಾಡಿ ಮೂವ್ ಆಗ್ತದೆ. ನಾವು ಈ ಕಡೆ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ, ಆಬ್ಜೆಕ್ಟ್ ಮೂವ್ ಆಗಬೇಕಿತ್ತು. Why it is moving along horizontal direction? ಹೇಗೆ perpendicular displacement ಅನ್ನು ತಗೊಂಡ್ವಿ. ಸಿ ಅದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್ಸ್ ಮತ್ತೆ ಕೊಡ್ತೀನಿ ನಾನು, ಬಟ್ ಈ ಡಯಾಗ್ರಾಮ್ ಮಾತ್ರ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಫಾರ್ ದಿಸ್ ಈಚ್ ಅಂಡ್ ಎವ್ರಿ ಕೇಸ್, ಮೂರು ಕೇಸ್ಗೂ ಮತ್ತೆ ಎಕ್ಸಾಂಪಲ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀನಿ. ಯಾವಾಗ ವರ್ಕ್ ಡನ್ ಪಾಸಿಟಿವ್ ಆಗುತ್ತೆ, when work done becomes negative, when work done becomes zero ಅಂತ. So for that I will just explain. ಆವಾಗ theta 0, theta 90, theta 90 ಕೇಸ್ ಕೂಡ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ ನಾವು, ರೈಟ್? ಸೊ ಅದಕ್ಕಾಗಿ 3 ಕೇಸಸ್ನ ನಾನು ತಗೊಂಡಿರೋದು. ಸೊ theta 90 ಆಗಿದ್ರೆ angle between the force and displacement is 90 degree. The angle between the force and displacement is 90 degree. And the force and the displacement ಏನಾಗಿದೆ, ಒಂದು perpendicular, right? So that is right. Force and displacement, force and displacement are perpendicular. They are perpendicular. Then it is applied to the formula work done is equal to Fx cos theta. What is theta? Theta is 90 degree. Cos 90 degree and the rest to 0. 0 into everything is 0. So work done equal to 0. Work done becomes equal to 0. Similarly, now applying this theta is equal to 180 degree. See now I am applying the force. So I am applying the force on this body, right? But my dear students, here you can answer. It is frictional force there, right? It is force applied by the object here. But we have given force there. Enta force is frictional force act, right? I have the frictional force. So I am just going to write frictional force. This is said to be the frictional force. F ಅಂತ ಬರೀತೀವಿ. ಇದರ frictional force ಅಂತ ಬರೀತೀವಿ. So frictional force ಇದೆ, right? So ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, I don't want to consider this applied force. ಇದು ನಾನು applied force ನ ಕನ್ಸಿಡರ್ ಮಾಡಕ್ಕೆ ಹೋಗಲ್ಲ. Assume that object is moving. ಆ ಬಾಡಿ ಏನಾಗ್ತದೆ, ಮೂವ್ ಆಗ್ತಾ ಇದೆ. ಬಟ್ ಇಲ್ಲೆಂತ ಫೋರ್ಸ್ ಇದೆ, frictional force ಇದೆ. ಇಲ್ಲೆಂತ ಫೋರ್ಸ್ ಇದೆ, frictional force ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ. What happens, frictional force ಏನು ಮಾಡುತ್ತೆ, ಈ ಬಾಡಿನ ಮೂವ್ ಆಗಕ್ಕೆ ಬಿಡಲ್ಲ. But object ಏನಾಗುತ್ತೆ, ತುಂಬಾ ಕಷ್ಟಪಟ್ಟು it is moving in forward direction by opposing this frictional force. And then displacement of frictional force opposite ಇದೆ, right? So ಏನಾಗುತ್ತೆ, frictional force ಈ object ನ ಮೂವ್ ಆಗಕ್ಕೆ ಬಿಡಲ್ಲ, ಬಟ್ ಈ object ಮೂವ್ ಆಗಕ್ಕೆ ಟ್ರೈ ಮಾಡುತ್ತೆ. ಆದ್ರೂ ಕೂಡ ಈ frictional force ಯಾವಾಗಲೂ ಬ್ಯಾಕ್ವರ್ಡ್ ಆಗಿ ಆಕ್ಟ್ ಆಗುತ್ತೆ. ನಿಮಗೆ ಗೊತ್ತಿದೆ, even while walking also there is a frictional force. So when frictional force oppose ಮಾಡ್ಕೊಂಡು we are moving, right? Suppose if I just consider that we have a washing machine, I want to just move that washing machine. What I want to do, washing machine or any object ದೊಡ್ಡ ಯಾವುದೋ object ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಅದಕ್ಕೆ ಒಂದೇನಾಗುತ್ತೆ, frictional force ಇರುತ್ತೆ. ಸಿ ನಾನು ಸುಮ್ಮನೆ ಸ್ವಲ್ಪ ಫೋರ್ಸ್ನ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ, if I apply a small force, so I just cannot take a simple example here. ಸೊ ಇಲ್ಲಿ ಒಂದು ಡಸ್ಟರ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ, ನಾನು ತುಂಬ ಗಟ್ಟಿಯಾಗಿ ಹೋಲ್ಡ್ ಮಾಡಿದ್ದೀನಿ. ಸೊ ನಾನು ಇಲ್ಲಿ ಸರ್ಫೇಸಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡಿದ್ದೀನಿ, ರೈಟ್? ಸೊ ನಾನು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ದೀನಿ. ನಾನು ಸುಮ್ಮನೆ ಏನು ಮಾಡ್ತಿದ್ದೀನಿ, ಸಿಂಪಲ್ ಸ್ಮಾಲ್ ಅಮೌಂಟ್ ಆಫ್ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಿದ್ದೀನಿ, ಮೂವ್ ಆಗ್ತಿಲ್ಲ. ನಮ್ಮ ಅಪ್ಲೈ ಲಾರ್ಜ್ ಅಮೌಂಟ್ ಆಫ್ ಫೋರ್ಸ್ ಮೂವ್ ಆಯಿತು. ಬಟ್ ಫಸ್ಟಿಗೆ ಯಾಕೆ ಮೂವ್ ಆಗಲಿಲ್ಲ, ಬಿಕಾಸ್ ಈ ಸರ್ಫೇಸ್ ಅಂದರೆ ಇಲ್ಲಿ ಸರ್ಫೇಸ್ ಇದೆಲ್ಲ, ಈ ಸರ್ಫೇಸ್ಗೆ ಈ ಡಸ್ಟರ್ಗೆ ಒಂದು ಇನರ್ಷಿಯಾ, ಅಂದರೆ ಡಸ್ಟರ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಇಟ್ಸ್ ಓನ್ ಇನರ್ಷಿಯಾ ಅಲ್ವಾ, ಅದಕ್ಕೆ ಒಂದು ಮಾಸ್ ಇದೆ, ಅದಕ್ಕೆ ಇನರ್ಷಿಯಾ ಇದೆ. ಇನರ್ಷಿಯಾ ಅಂದರೆ ಏನು, ಯಾವಾಗಲೂ ಕೂಡ ಇಟ್ ಆಕ್ಟ್ಸ್ ಇನ್ ದ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್. So the frictional force always acts in the opposite direction, so that the frictional force and the displacement are always opposite to each other. The object move ಆಗ್ತಾ ಇದೆ, ಬಟ್ ಅದು ಮೂವ್ ಆಗೋದನ್ನ ಈ ಸರ್ಫೇಸ್ ತಡೆಯುತ್ತೆ. ಸೊ ಅದನ್ನ frictional force ಅಂತ ಕರೀತೀನಿ. ಇಲ್ಲೇನಿದೆ, this force and displacement ಅದನ್ನೇ ಅಂತ ಕರೀಬಹುದು, ಪ್ಯಾರಲಲ್ ಅಂತ ಕರೀಬಹುದು, ಆಂಟಿ ಪ್ಯಾರಲಲ್ ಅಂತ ಕರೀಬಹುದು. Those are anti parallel. Anti parallel ಅಂದ್ರೆ angle ಎಷ್ಟಿರುತ್ತೆ, 180 degree ಇರುತ್ತೆ. So ಹಾಗಾದ್ರೆ let us apply this. W is equal to f x cos theta. So f x cos into 180 cos 180 cos 180 and minus 1. And then we got minus fx minus f into x. See my dear students, ಹಾಗಾದ್ರೆ ಯಾವಾಗ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಗಿರುತ್ತೆ theta 0 ಇದ್ದಾಗ ವರ್ಕ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಗುತ್ತೆ ಬರೀರಿ. So ಮೂರು ಕೇಸ್ ಬರೀಬೇಕು. So you should write the three cases in the diagram and also this thing. So calendar work is maximum when theta is equal to 0 and work is minimum when theta is equal to 90 degree and work is negative when theta is equal to 180. Right. In this case, it is positive and maximum. Work is positive and maximum. Last one line bari. Work is positive and maximum. Work is minimum and zero. Work is negative. Work is minimum and zero. Our case alli work is negative. So in this mood case alli ನಾವು ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ವಿ, we got work may become positive when the force and displacement are parallel to each other or when the force and displacement are along the same direction. So when the force and displacement are perpendicular, work becomes zero or minimum. When the force and displacement are opposite to each other, when they are anti-parallel, when the angle between them is 180 degree, the work done is negative. So the work done is minimum at zero, work done is maximum, work done is negative. See, the three cases we got again. Work done may become positive, work done may become zero, and work done may be negative. So the work done positive it becomes negative also, even it becomes zero also. Then now let us discuss when the work is positive, when the work is negative, and when the work will be equal to zero. Examples na barita hogoಣ. ಹೌದಾ? ಬಿಕಾಸ್ ಆಲ್ರೆಡಿ ನೀವು ಮಟ್ಟ ಅಬ್ಸರ್ವ್ ಥೀಟಾನ ಅಬ್ಸರ್ವ್ ಮಾಡಿಬಿಟ್ಟಿದ್ದೀರಾ, ಅಲ್ಲೇ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿಬಿಟ್ಟಿದ್ದೀವಿ. ಸೊ ಅದರ ಕೇಸಸ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಆಗಿರೋದ್ರಿಂದ ಜಸ್ಟ್ ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ದ ಎಕ್ಸಾಂಪಲ್ಸ್ ಅಷ್ಟೇ. ಸೊ ಲೆಟ್ ಡೌನ್ ದ ಹೆಡಿಂಗ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಫಾರ್ ಪಾಸಿಟಿವ್ ವರ್ಕ್ ಡನ್. ಎಸ್, ಎಕ್ಸಾಂಪಲ್ಸ್ ಫಾರ್ ಪಾಸಿಟಿವ್ ವರ್ಕ್ ಡನ್ ಅಂತ ಹೇಳಿದ್ರು. ಸಿ ಪಾಸಿಟಿವ್ ವರ್ಕ್ ಡನ್ಗೆ ಐ ಕ್ಯಾನ್ ಗಿವ್ ಅ ಲಾಟ್ ಆಫ್ ಎಕ್ಸಾಂಪಲ್ಸ್. ಯಾವ ಥರ ಕೊಡ್ಬೋದು ಪಾಸಿಟಿವ್ ವರ್ಕ್ ಡನ್ಗೆ lot of examples ಅಂತಂದ್ರೆ my dear students. So you know that ಒಂದು horse ಏನಾಗುತ್ತೆ, horse is going to pull a cart. Pulling examples for positive work done. Heading ಏನಾಗಬೇಕು, examples for positive work done. ನಾನು ಬರೆಸ್ತೀನಿ ಬಟ್ ಅಲ್ಲಿ ತನಕ ಬರಿಬೇಡಿ. ಸೊ horse pulling a cart, it is also an example for positive work done. ಹೇಗೆ ಹೇಳ್ತೀರಾ ಅಂದರೆ ಪಾಸಿಟಿವ್ ವರ್ಕ್ ಡನ್ಗೆ ಎಕ್ಸಾಂಪಲ್ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು. ಸೊ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಈ ಕೇಸಲ್ಲಿ ಸೊ ಒಂದು horse ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿ, ನಾವು ಡ್ರಾ ದ horse exactly. horse ಬರೀಲಿಕ್ಕಾಗಲ್ಲ, ಇವಾಗ horse ಅಂತ ಹಾಕಿದ್ದೀನಿ. Here it is connected with a cart, right? It is connected with a cart. So simply I will just write like this. The horse is just going to pull this cart. Horse is going to pull the cart. And ಮಾಡುತ್ತೆ also it applies the force in this direction. ಅದಕ್ಕೆ ಈ cart ಏನು ಮಾಡುತ್ತೆ, ಮೂವ್ ಆಗೋಕ್ಕೆ ಶುರು ಮಾಡುತ್ತೆ. The force ಮತ್ತು displacement ಎರಡು ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಇದೆ, ಅದಕ್ಕೆ ವರ್ಕ್ ಏನಾಗುತ್ತೆ, ಪಾಸಿಟಿವ್ ಆಗುತ್ತೆ. ವರ್ಕ್ becomes maximum also. Similarly, we can give other examples also, my dear students. Which are those examples? A body which is lifted upwards. It means if I just have this one, so on surface I can consider matter. I am lifting this object upwards. Andre ನಾನು ಫೋರ್ಸ್ ಯಾವ ಕಡೆ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಮೇಲ್ಗಡೆ, ಅದೇ ಥರ ಆಬ್ಜೆಕ್ಟ್ ಯಾವ ಕಡೆ ಮೂವ್ ಆಗುತ್ತೆ, ಮೇಲ್ಗಡೆನೇ ಮೂವ್ ಆಗುತ್ತೆ. ಅಂದರೆ ಫೋರ್ಸ್ ಅಪ್ಲೈಡ್ is upwards, object moved is upwards. The motion of the object is displaced upwards, as well as the force applied is also in the upward direction. So the force and the displacement both are in the same direction. Lifting a body in the upward direction is also an example for the which one, positive work done. ಅಷ್ಟೇ ಅಲ್ಲ, even you can observe the stretched spring. And the stretched spring again, you spring observe right? You might have observed the spring observe but spring you expand expand see you eddy spring and your force is in this direction. This displacement spring move along the direction of force, and the displacement is along the same direction. You have force apply spring move. See more example. One is lifting a book, another one is pulling a car, third one is expansion of the spring. Right? So take down the examples. The first point is when horse pulls a car, the force and displacement are in the same direction. So the work done is positive. We'll stop. Next point. Lifting a body upwards. Lifting a body upwards. Second and third example. Stretching a spring. Yes. Fourth one. A body falling freely under the gravity. For body falling freely under the gravity, because one object, if I just allow this object to fall freely under the gravity, so force of gravity is acting downwards. Other see you can observe that object displacement so object falling freely under the gravity is also an example for positive work. So, force and displacement are in the same direction. We can say that the work is positive. Theta 0 agutte. Yavaga force and displacement parallel aguttave. Work that is positive. So, I just given you the 4 examples. Object falling freely under the gravity, lifting an object, and stretching a spring. Another one is pulling a cord by the arms. These are all the examples for positive work done. Now, my dear students, let us move towards when the work becomes negative. Yavaga work negative agutte. And ಈಗ ಒಂದು 3 example ಕೊಟ್ಟೆ. ಆ 3 example ಅಲ್ಲಿ ಒಂದು example ಏನಾಗಿತ್ತು body lifting ಅಂತ ಹೇಳಿ. See my dear students, lifting a body ಅಂತ ಬಂದ ತಕ್ಷಣ see I am just going to take. So observe that this is an object, this is a book, right? Assume that this is a book. So what I am just doing is I am just going to lift this book upwards. ಇದನ್ನ ಮಾಡ್ತೀನಿ ಮೇಲ್ಗಡೆಗೆ ಲಿಫ್ಟ್ ಮಾಡ್ತೀನಿ. right ಮೇಲ್ಗಡೆ ಲಿಫ್ಟ್ ಮಾಡ್ತೀನಿ. ಲಿಫ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂತ assume that ಈ ತರ ಇದೆ. ಇದನ್ನ ಮೇಲ್ಗಡೆ ಲಿಫ್ಟ್ ಮಾಡಿದ್ದೀನಿ. ಇಲ್ಲೆಲ್ಲೋ ಇದೆ ಲಿಫ್ಟ್ ಮಾಡಿರೋದಕ್ಕೆ. ಗ್ರೌಂಡ್ ಇಂದ ಮೇಲ್ಗಡೆ ಲಿಫ್ಟ್ ಮಾಡ್ತೀನಿ. The ground I lifted it upwards. So ಇಲ್ಲೆಲ್ಲೋ ಇದೆ. It means at this point ಕೆಳಗಡೆ force of gravity act ಆಗ್ತಿರುತ್ತೆ. ನಾನು ಬಿಟ್ಟ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ ಡಸ್ಟ್ falls to the ground. ಅಂದ್ರೆ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ towards the downward direction force of gravity is acting. ನಾನು ಮೇಲ್ಗಡೆಗೆ pull ಮಾಡಿದಾಗ ಆಬ್ಜೆಕ್ಟ್ ಮೇಲ್ಗಡೆ ಮೂವ್ ಆಗುತ್ತೆ. ನಾನು ಅಪ್ಲೈ ಮಾಡಿರೋ ಫೋರ್ಸ್ ಮೇಲ್ಗಡೆ. Here applied force ಅಂತ ಬರೀತಾ ಇದ್ದೀನಿ. Applied force is upward. Displacement is upward. ಹಾಗಾದ್ರೆ ಈ ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ lifting a book, lifting an object, lifting a duster, ಈ ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ applied force displacement same direction ಇದೆ, ಅದಕ್ಕೆ work done positive ಆಗುತ್ತೆ. But work done negative ಕೂಡ same example we can give, because ಎಲ್ಲೋ ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಇದೆ ಅಂತ ಅಂದಾಗ at some height ಅಂದಾಗ force of gravity always acts in the downward direction. Force of gravity always acts in the downward direction. Actually, this is the force of gravity. You ಬೇಕಾದ್ರೆ diagram ಅಂತ ಬರ್ಕೋಬಹುದು ಅಲ್ಲಿ, right? So ಇಲ್ಲಿ ನೀವು ಬೇಕಾದ್ರೆ diagram ಹತ್ರ note ಅಂತ ಹಾಕೊಂಡು ಬರ್ಕೊಂಡ್ಬಿಡಿ, ಈಸಿ ಆಗುತ್ತೆ note ಅಂತ ಹಾಕೊಂಡು, right? note ಅಂತ ಹಾಕೊಂಡು ಇದನ್ನ ಬರ್ಕೋಬಹುದು. So lifting a object upwards, lifting a body upwards ಅಂತ ಬರ್ಕೊಂಡು. So write this diagram. So ಇಲ್ಲಿ ಬರ್ಕೊಂತೀರಾ ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಮತ್ತೆ ಪಾಯಿಂಟ್ A ಏನಂತ ಬರೀರಿ, applied force and displacement are in the same direction, work done is positive. Next point now, see force of gravity and displacement. Displacement upward direction da, force of gravity downward direction da. It means force of gravity and the displacement are acting in opposite direction. Then work done ಏನಾಗುತ್ತೆ ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ ಬಿಕಾಸ್ ಎರಡು ಅಪೋಸಿಟ್ ಇದೆ ಆಂಟಿ ಪ್ಯಾರಲಲ್ ಇದೆ. ಹಾಗಾದ್ರೆ ಇವೆರಡು ಮಧ್ಯೆ ನಮ್ಮ ಆಂಗಲ್ ಎಷ್ಟು 180 ಡಿಗ್ರಿ ಆಗುತ್ತೆ. ಹೌದಾ? ಅದಕ್ಕೆ ಏನಾಗುತ್ತೆ ಬಿಕಾಸ್ ನೆಗೆಟಿವ್. ಸಿ one example ಅಲ್ಲಿ we can just give you that the work done is positive as well as we can show that the work done is negative also. So note ಅಲ್ಲಿ this example ತಗೊಂಡಿದ್ದೀರಾ. ಅದೇ ತರನೇ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡ್ಬಿಡೋಣ. ನೋಟ್ ಅಲ್ಲಿ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡ್ಬಿಡೋಣ. ಸೆಕೆಂಡ್ ಎಕ್ಸಾಂಪಲ್ ನೋಟ್. ಸೊ ಈಗ ಒಂದು horizontal surface ಇದೆ. horizontal surface ಇದ್ರ ಮೇಲೆ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ನ ಪ್ಲೇಸ್ ಮಾಡ್ತೀನಿ. I am going to place an object body of mass m, right? So ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, I am applying a force and force ನ apply ಮಾಡ್ತೀನಿ object ಮೇಲೆ. Due to the application of a force, the object moves with the displacement x, right? ಇದಂತ force this is applied force. ನಾನು apply ಮಾಡಿರೋ force. So applied force and x are in the same direction. So work done ಏನಾಗುತ್ತೆ same direction ಇದ್ರೆ it becomes positive. So in first point only, the applied force and the displacement are in the same direction. So the work done becomes positive. But in observe madri, unknown force is that frictional force. That frictional force is represented by F. So frictional force is always opposite to the direction of motion of the object. Adu nimage gottida munchene. Friction is always opposes the motion of an object. So this frictional force is opposite to which one? Displacement. ಹಾಗಾದ್ರೆ frictional force displacement ಗೆ opposite ಇರೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ ನಿಮಗೆ what happens to the work done? It becomes negative. So B point ಬರ್ಕೊಳ್ಳಿ. So that the frictional force is opposite to the displacement. Therefore the work done becomes negative. Therefore the work done becomes negative. This is about the mode. Now you can take another example also. The example ತಗೊಳ್ಳೋಣ. So which one that example? Let us take next heading, examples for negative work done. So ಅದರಲ್ಲಿ first ಎರಡು example ತೋರಿಸ್ತಾರೆ. ಒಂದು frictional force ಮತ್ತೊಂದು ಯಾವುದು ತೋರಿಸ್ತಾರೆ ನಿಮಗೆ force of gravity ಅಂತ ತೋರಿಸ್ತಾರೆ. ಅದನ್ನ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ಳಿ first. So first point, when a body is lifted, work done by the force of gravity is negative. Full stop. Yes. ಇದು ನಿಮಗೆ ಅರ್ಥ ಆಗಬೇಕು ಅಂದ್ರೆ ನೋಟ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಬರ್ಕೊಂಡಿದ್ದೀರಾ. ಅದಕ್ಕೆ ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಹಾಕ್ತೀವಿ. ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಇನ್ ಬ್ರಾಕೆಟ್ ರೆಫರ್ ನೋಟ್ ನಂಬರ್ 1. ಎಸ್, ಅಲ್ಲಿ ನಿಮಗೆ ಅದು ನೋಟ್ ಡಯಾಗ್ರಾಮ್ ನೋಡಿದ್ರೆ ಅರ್ಥ ಆಗ್ತದೆ. ಎಸ್, ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಎಕ್ಸಾಂಪಲ್. The frictional force acting on an object gives you negative work done. Full stop. In bracket, refer note number 2. Refer note number 2. Yes. See my dear students, ಇದನ್ನ ಒಂದು natural example ಕೊಡೋಣ. So suppose if I am moving in a vehicle, ಬ್ರೇಕ್ ಅಪ್ಲೈ ಮಾಡಿದ ತಕ್ಷಣ ಏನಾಗುತ್ತಾ? ಸೊ ನಿಮಗೆ ಗೊತ್ತಿದೆ, ಬ್ರೇಕ್ ಅಪ್ಲೈ ಮಾಡಿದ ತಕ್ಷಣ ಬ್ರೇಕಿಂಗ್ ಫೋರ್ಸ್ ಮತ್ತು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಎರಡೂ ಕೂಡ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನಲ್ಲಿ ಇರುತ್ತೆ. ಸೊ ಹಾಗಾದರೆ ಆ ವರ್ಕ್ ಡನ್ ಬೈ ದ ಬ್ರೇಕಿಂಗ್ ಫೋರ್ಸ್ ಏನಾಗಿರುತ್ತೆ? ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ. ಅದನ್ನು ಒಂದು ಬರ್ಕೋಬೋದು ನೀವು. ಸೊ ದಟ್ ಬ್ರೇಕ್ ಅಪ್ಲೈಡ್ ಆನ್ ಮೂವಿಂಗ್ ವೆಹಿಕಲ್ ಗಿವ್ಸ್ ಯು ನೆಗೆಟಿವ್ ವರ್ಕ್ ಡನ್ because braking force and the displacement are in opposite direction. Okay, yes. This is about the examples for which one? Negative work done. Now let us move on the examples for zero work done. What we can give the zero work done? Just example ಕೊಡಬಹುದು. Lot of examples. See, take the idea. Take down the idea. Examples for zero work done. So we can give the first example that suppose if displacement is zero, if displacement is equal to zero, displacement zero ಆದರೆ obviously work done ಏನಾಗುತ್ತೆ? Zero ಆಗುತ್ತೆ, right? So first example, take down that if the displacement is 0, comma, work done is said to be 0. Work done is said to be 0. Yes. So the next example. See my dear students, so we can say that suppose ಯಾವುದೋ ಒಂದು object circular motion ಅಲ್ಲಿ move ಆಗ್ತಾ ಇದೆ ಅಂತ right. So let us consider that ball is a stone is tied to a rope and it is rotated in a circular path. ಹಾಗಾದ್ರೆ ಒಂದು stone ಇದೆ. So ಇದನ್ನ rotate ಮಾಡ್ತಾ ಇದೆ circular right. It is rotated in a circular path. So ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಅದು ಯಾವ ಕಡೆ ಮೂವ್ ಆಗುತ್ತೆ? This is a displacement, right? Force act on the centripetal force, so it is towards the center of the circular path. ಇವೆರಡರ ಮಧ್ಯೆ ಇರೋ angle ಎಷ್ಟು? 90 degree. ಹಾಗಾದ್ರೆ what happens to the work done becomes negative. When the force and displacement are perpendicular to each other, the work done becomes 0, right? So take down that point. The work done by the centripetal force on rotating body is 0. Yes, stop. You can take down that diagram to understand it clearly. 2 examples we written. So still you can move for different examples. Take down another one example. The force in the string of simple pendulum. The force in the string of simple pendulum gives you 0 work done. Right. See, one string gives you 0 work done because when you simple pendulum force here. So we stand here on the ball ತಗೊಂಡು ಅದನ್ನ ಏನು ಮಾಡ್ತೀವಿ oscillate ಮಾಡ್ತೀವಿ right. So oscillate ಮಾಡಿದಾಗ so it moves like this. So it moves like this. ಈ ಕಡೆ move ಆಗಿ ವಾಪಸ್ move ಆಗ್ತಾ ಇರುತ್ತೆ. So ಈ ತರ move ಆಗಬೇಕಾದ್ರೆ so force ಎಲ್ಲ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ. Force is acted on the string towards this pivoted point. ಅಂದ್ರೆ ಎಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವೋ ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಈಗ ಆಸಿಲೇಟ್ ಆಗ್ತಾ ಇದೆ ರೈಟ್. ಆಸಿಲೇಟ್ ಆಗಬೇಕಾದ್ರೆ what is the displacement position? The displacement is this. So see, even I can show you that. The displacement is this, right? E point alli displacement is this. E point alli displacement is this. So the angle is 90 degree. Angle is 90 degree. Angle is 90 degree. The force is towards the center. Force is towards the center. So when the angle between the force and the displacement is 90 degree, it means the object in move ಆಗಬೇಕಿತ್ತು. But ಇಲ್ಲಿ centripetal force ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ pendulum ಅಲ್ಲಿ string ಮೇಲೆ act ಆಗ್ತಿರೋ force ಇರೋದ್ರಿಂದ so ಏನಾಗ್ತದೆ ಈ ಬಾಬ್ displace ಆಗ್ತದೆ. So this is the direction, but ಇಲ್ಲಿ force ಇರೋದ್ರಿಂದ oscillate ಆಗುತ್ತೆ. So the force, the angle between force and the displacement is 90 degree. Then what happens to the work done? It becomes 0. So you can write the diagram also. This is all the examples for your 0 work done. So dear students, today almost we completed the introductory part of this chapter. So the next class will move on to the work done. Right? Thank you.